I used the wrong mouse. I was trying to start another video, so I used the wrong mouse for that. So the F denotes the number of degrees of freedom, and for this sample of 23 cars is 22. Anything else?
I guess question 6. Oh, yeah, same thought right there. Good choice.
Well done. Okay. A simple random sample of size n equals 40 is drawn from a population. The sample mean is found to be 104.3, and the sample standard deviation is found to be 23.7. Is the population mean greater than 100 at the alpha such and such? So what do we write as H naught or H0? We're testing whether the population
It's equal to 100.
Excellent. And H1 or
Greater than 100.
Greater than 100. And they all have to be mu. Careful, because sometimes they throw in a population proportion. Computer test statistic, okay? I'll do it with the calculator. So we are looking at t-test, and we are using stats. Mu0 is 100. X bar is given to us 104.3. Standard deviation 23.7. Sample size 40. And we want a right tail test. So I determined that the test statistic is 1.1475. 2 decimal places is needed. So this is a t, of course, and we have, it says 2 decimal places, so I got 1.15, 1.15. Determine the p-value. We already have it. How many? Around to 3 decimal places that is needed. 0.013. What is the result of the hypothesis test? So the p-value is 0.13. Alpha is 0.1. Which one is bigger, p-value or alpha? I know it's a silly question. P-value 0.13, alpha 0.1. Which one is bigger?
Reject, because the p-value is larger.
Never. Only when the p-value is smaller.
Yeah, that's right.
So we fail to reject. Do not reject the null hypothesis because the p-value is greater than the level of significance at the, full stop. At the alpha 0.1 level of significance, the population mean is or is not less than, okay, so since we fail to reject, the population, I don't know, because I can't see both at the same time, so I'm going to choose is, and then I go back and correct if I need to. So since we fail to reject, okay, careful. So it's not. So at the alpha 0.1 level of significance, the population mean is not greater than 100. Is not greater than 100. It's not different, it's not less, it's not different, no. So let's read the sentence one more time before we click check answer. Do not reject the null hypothesis because the p-value is greater than the level of significance. True. At alpha 0.1 level of significance, the population mean. So the sample, the data coming from the sample does not support that it's greater, because we fail to reject the null hypothesis. So it appears that the sample supports the null hypothesis. So the population mean is not greater than 100. I strongly recommend reading this at least twice before you choose, so you don't make an error and have to go back. Okay. Anything else?
9.
9. Okay, the average daily volume of a computer stock in 2011 was this: million shares. According to a reliable source, a stock analyst believes that the stock volume in 2014 is different from this. Based on a random sample of 30 trading days in 2014, he finds the sample mean to be 32.5 million shares with a standard deviation of. Test the hypothesis by constructing a 95% confidence interval because it's different. If the keyword different weren't there, I would have not been able to use a 95% confidence interval for that. But I am able to because it's a two-tailed test. So then this is for mu, and this is equal, and this is for mu, of course, and this is not equal to. So that's the first thing we need to do. Then construct a 95% confidence interval. So let's take the calculator. And this time we go to second and we go to stat and tests. And we want a t interval. T interval. Okay, so with statistics, sample mean 32.2, 32.5, sorry. Standard deviation 12.3. Sample size 30. Confidence level 0.95, and calculate. So the lower limit, round to 3 decimal places as needed. I got 27.907, the lower bound, and the upper bound 37.093, 3 decimal places. And then, okay, so this interval, does it include the sample mean? Where is my sample mean? 32.5. Does it include 32.5? Does this? Yes, it does. So we have to fail to reject. We will fail to reject. Do not reject the null hypothesis. So I have to read the do not reject. I will not even read B and D. I normally read all of them, but I know I have to fail to reject. It's not a rejection situation. So I'm only going to read A and C. Did not reject the null hypothesis because mu equals 35 shares false. Who cares? No. Who cares about 35.1? We're talking about 32.5. Did not reject the null hypothesis because it's the population mean. Sorry, that it's the null hypothesis. That's correct. Mueller's does not fail. Okay, does not fall in the confidence interval. It does. So do not reject the null hypothesis because 35.1 million shares falls in the confidence interval. That's correct. So C, again, do not reject the null hypothesis because this does not fall. It does fall. 35 is here. So the null hypothesis, the mean, is in this interval. So based on the sample, we use 32.5 to create the 95% confidence interval. That's how we got it. So the sample supports the null hypothesis. Do not reject, because 35.1 is in the confidence interval that we determined. Very good pick. This was a nice problem. Again, we can do that only when we look at a two-tailed test with a confidence interval. Good pick.
10 looks fine as well.
Okay.
That came up next.
Very good. Okay, in the 2015 AFC Championship game, there was a charge in the New England. What is it? So my device is so far away from me. I'm trying to read it. Sorry about that. There was a charge. The New England Patriots. Okay, I heard about that. Underinflated their footballs for an advantage. The balls should be inflated to between this and this pounds per square inch. Okay. The accompanying data consists of 11 of the 22 measurements on the Patriots footballs. Okay. Complete parts A and B. Okay, so let's put the data in the calculator. So clear if you have there or not. We'll go to the next table. So I have 11. It's a good one. Thank you for picking that. 11.5, 11.1, 12.3, 11.95, 11.8, 11.6, 11.15, 11.35, 10.9. Okay, do I have 11? 11, yes. Okay, so degrees of freedom, 10. Test the hypothesis that the population mean is less than 12.5 psi. Using a significance level of 0.05, state clearly whether the Patriots footballs are underinflated or not. Assume the conditions for hypothesis test are satisfied. So we don't have to test anything because they are telling us to assume that they are all satisfied. Determine the null and alternative hypothesis. Choose the correct answer. So again, test the hypothesis that the population mean is less than. So do we choose A? Do we choose B, C, D, E, or F?
E.
Less than. The key word here is less than.
B.
B looks good. This is not possible. This is not possible. This is not the key. This is it's less than. Okay. This is not the possible. This is not possible. I agree with B. Good. The test statistic is, so we have the data. Go to stats, go to tests, and this is a t-test. And this time we have the data. Mu0. Where is our mu0? Should be inflated to between this and this per squared inch. The accompanying, so that's our 12.5. 12.5. List L1, and we are looking at the left tail test. They're underinflated, and we draw. So I got negative 7.45. Did anyone else get that number? If not, I'll do it again, just to make sure. Maybe I'm checking my data, see if I copied everything correctly. 11, 11.85. If anyone can confirm, then I don't have to check. 12.3, 11.95, 11.8, 11.6, 11.15, 35, 90. Did anyone else get the same result? So 12.5. Yes? Anyone?
Yes.
Okay, so then I'm going to enter negative 7.2 decimal places, negative 7.45. Negative 7.45. And the p-value is 0. And now, the p-value is greater than alpha 0.05 or smaller than alpha. Anyone? Is the p-value smaller or larger than alpha? I know it's a silly question. I'm sorry. So, since the p-value is less than, it means that the test statistic is in the rejection area. So, a p-value is less than or equal to the significance level, reject H naught. There is sufficient evidence to conclude that the population mean is less than 12.5 psi at a significance level of 0.05. Using only the given measurements, it appears that the Patriots balls where we rejected the null hypothesis that they were within the norms. They were not, according to the sample. There is sufficient evidence to conclude that the population mean is less than 12.5 psi at a significance level of 0.05. Using only the given measurements, we don't have anything else, just these 11 pieces of information that make up the simple random sample, it appears that the Patriots balls were underinflated. Oh, there is more. Use the data to construct a 95% confidence interval for the mean PSI for the Patriots footballs. How does the confidence interval support your conclusion in part A? We can determine, but this is not a two-tailed test. So let's create a confidence interval. So stat test, we want a t interval, and we are using the data, and we want a 95%, and we want to calculate. So round to 2 decimal places. So I got 11.20 to 11.8. So this does not include the 12.5. So I guess it's okay. So the confidence interval supports the conclusion in part A because the value 12.5 is not is above. Yep. So one more time. As you see, the 12.5 is above the interval. In other words, it's not in the interval. So the confidence interval supports the conclusion in part A because the value of 12.5 is above. In other words, it's not in the confidence interval. Any questions?